Our next speaker comes all the way from Texas. He and I worked for the same company for a while called Microsoft. He's very devoted to the world of healthcare and especially mental health. And he's been using Ori for a few years, and he's a big and excited fan of what Ori's doing. So we're very happy to have him here today. He's going to talk to us about his application in the healthcare space and some of the challenges he faced developing that with Ori, and maybe some of the highlights as well. Travis, thank you for coming, and good luck.
All right, thank you. So a little bit about me. Okay. Great. I'm Travis James, and I hail from Dallas, Texas, you know, the home of the world's favorite sports franchise, the Dallas Cowboys. Sorry, I'm an Eagles fan. Yeah, they're like number 3 or 4, you know. But seriously, I love the Ori product. We've had it adopted for a long time. My company is called Tribe Health Solutions. And what we do is we build data management solutions for healthcare. Right now, we're focused more on mental health, but it's really generically across all healthcare to help individuals be able to take control of their own user data in how they collect it and how they share it. And you'll see where this leads to some interesting questions when it comes to use of identity. There we go. Got it. Okay. At the core of our product is we have a thing we call Tribe Core, which is our core platform of which Ori is a huge part. There are 2 very, very important parts of our platform. One is Ori that provides our identity management, and number 2 is Supabase, which provides it's like a sidecar to your database that provides you some functions that are very similar to like Firebase. It allows you to expose, use schemas to expose APIs, GraphQL, open APIs, just based off the schema. So using our platform, very similar to low-no code in that you can basically specify the types of things that you want to manage, the rights behind those things that get implemented by Ori's products, including Hydra, Kiddo, and of course, Kratos, and allows you to basically patch together a framework for handling things like workflow and all of that related to your data and integrations to external entities here. So that's what we're showing here. So what we have found is that it's very, very important to have all of your AI principles, whatever AI you want, as part of your core platform as opposed to trying to bolt it on later. So that's where Supabase really, really helps out a lot because they provide a vector database, right, that you can use for straight similarity search or to help you interact with large language models by adding context to your prompts. And the functions facility provides us a way to integrate with various generative AI models, one or more of them, using those vector components. And then we hook in to know when a user has logged in, so we can generate automatically, all of the structures that are needed to handle their personal data that is stored in our platform. And then here's an idea of how you can leverage all of this to build your own plugins to ChatGPT. So a core principle of ours, in order to really allow users to take full control of their medical data, is decentralization. You really can't accomplish it by just creating another silo and sticking all the data in there. You have to have a way that users are the sovereign owner of their own data. And the way we do this is we basically piggyback off of the work on IPFS, which is based on libp2p, which allows us to describe an infrastructure of nodes that communicate with each other, and then use conflict-free resolution to basically replicate all of the CIDs related to either data or like with IPFS that relates to files, it's basically piggybacking on IPLD to allow you to create structures of data that gets pushed all throughout the infrastructure. So you can see here what we have here is there's a healthcare system node where basically we've been talking to some healthcare systems in the United States where they would like to use this for managing like access to their patient portals and things like that. And then you have the ecosystem provider node, which could be something like my brother. My brother is a spine surgeon in Southlake, Texas, and he would potentially have a node on his site. This was our first prototype, a node on his site that can read MRIs that are taken in an imaging center and have those things replicated via IPFS down to his system where they had a way for to read them right into the current viewers that he has, the DICOM viewers that he has. So that allows him to not change his workflow at all, but then be able to immediately consume those MRIs, which take about 35 minutes out of his day to actually take the CD, copy it, put it in his system and all that. We can automate all of that through this system. So the use case, though, I want to talk about is our mental health use case. This is a very personal use case for me because I actually have a son, 23 years old, who is schizophrenic. Now, my son is also a phenomenal artist and a musician. He's self-taught. I mean, it's amazing things that he can do. And a lot of times, mental illness kind of goes hand in hand with some of these gifts. And so, it's very easy to say, okay, I'm going to ship him off to some institution, but then he gets heavily medicated, his gifts are dulled, and then he just, and he's lost forever. So one of the things that's been a passion of mine is putting together a series of tools in an ecosystem that will allow me to manage his care, ensure that all the data that's necessary for him, his history, especially when you want to move to another psychiatrist, that they can know all the history of everything he's taken and what doses, amounts, and then and more importantly, be able to find a way to push in how he felt during these times through journaling and these other tools. So in order to be able to do something like that, you need a system like what we're building. And to take advantage of the influx funnel, we have a patient that can then take assessments that tell them kind of where they are on the spectrum of all of the other of all these psychiatric conditions. There's one big one that's called the mini exam that we support. That is very long, it's 2 hours long or whatever. But there's several others that can give you an indicator of where you fall on like ADHD, PTSD, bipolar, schizophrenia, and all these other illnesses. And the thing that is cool about our system is that once we collect that data, it is stored for that patient, encrypted for that patient. So because there's a stigma, especially in the United States, attached with mental illness. We built a system a couple of years ago for police officers to help them get mental health care, in response to things like shootings and things like that they encounter on their job. And that is a profession where they don't want anybody to know they're even looking at it. So we built a system that would bring content to them, allow them to take an assessment, and then the assessment results are, of course, stored securely. And anytime a user can seek help, when they decide to seek help, at that point they can use their identity to provide the keys to the encrypted data to share with another provider in the same manner that I discussed, in the previous slide. So when it comes to generative AI, the key is to be able to attach user context to these prompts in a ubiquitous way. That's what we're working on. So essentially what we want to be able to do is take a user identity and be able to use the Supabase and a vector database support to pull things off and then funnel it through a LangChain pipeline. And there's basically some pseudocode there that in this particular case, the scenario we're talking about, is that we can store all of user context inside a SQLite database. Every machine has some implementation to read off SQLite. And most of them have also support for SQL Cipher, which then allows you to provide an encryption key to that. They can provide later, they can provide out of band, so that then you can read that database. And then we create a standard for like the types of schemas that you would need in order to support looking up what did this database have, where are the tables, and what you're looking for, and the rights and stuff that are supposed to be there. So in this case, what we're showing is that you can kind of select a demographic embedding where you user ID equals X, and then you can actually evaluate on a prompt what steps are best to get mental health care treatment for me. That's a generic question that will probably have some other vector database content depending on the owner of the system has their own context. All right, and then so you combine the two contexts together and get very, very specific answers. And that's the thing that we feel is pretty exciting about that. So here's some options for storing user context. I talked about storing it inside on the right there, totally under user control, using IPFS to store the data, and then piggybacking off of decentralized identity. We do some work with the Decentralized Identity Foundation to enable you to have a opaque way to represent yourself, right? That is inside of your wallet. And that can be paired with verifiable credentials, which was mentioned in another talk, to basically certify the person has the types of credentials that they're supposed to have. And then we can use OpenID connectors to associate those decentralized identities back to an ORI identity. And so it seamlessly flows in. And that's where I'm excited about using this passkey thing too, because then now you can just whip out and use your, you can authenticate using a combination of your wallet and the passkey into any system. And then, and part of that, intrinsic to that, is the information that you would need to pull in context from IPFS, which has all the other data you're looking for, right? And so, but on the left, you can also store user context on a per node basis, utilizing row-level security inside of Supabase and other tools. And then you can attach the user context. You can encrypt those fields. You can do encryption at a level where the owner of the keys for encrypting the fields that you can read, go along with the context. And then you can store these keys in the user wallet along with the identity and pass them in with the user sessions. So now let's talk about the future, because all this presumes that maybe you're talking to ChatGPT or you're talking to Claude 2 or one of the other hosted models, right? But as we see this rapid, evolution happening right now, just all across the landscape of large language models, and it has to do with not, going with like a billion trillion parameter, model and going and making them just bigger, 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 but actually making them smaller and tuned to purpose, tuned to task. So to give you an example, here are some models here that I listed. The current favorite model for me, which might change tomorrow because there's so many different ones coming out, is Zephyr, which is derived from Mistral. But any of these models, Llama 2, Mistral, and Zephyr, they come in 7 billion parameter sizes that then you can convert, to run on just about any device. And you can see where they stack, especially Zephyr, their stacks there, as comparing that to, it's very close to the performance of GPT-4 and Claude down here, which are industry standards. So this is, and you can get all this on the Hugging Face site. I encourage anybody to go out there and play around because they have everything. They have, the performance numbers and everything for every model that's out there. So because you can use smaller models to get the same efficiency that you would get for GPT-4, you're able now to do generative AI on the edge, which is the secret sauce that we're doing the most work on right now. And that is that models, you can prepare the models, to run on any device. You do that by first you quantize it. Models come in like 32-bit variation. You can quantize the model down to 4 bits. convert the model to O in an X format, which makes it generic, such that it can run on either on Core ML if you're on an iOS platform, or it can run under TensorFlow Lite on an Android platform. Each of those platforms has their own chip dedicated to those things, so that then you don't eat up the power on the doing inference. You don't eat up the power on the phone, and you don't need as many resources. And on the desktop, you can quantize models using GGUF, which is a newer quantized method, along with Llama CPP to perform inferences with minimal loss. So basically, you quantize it, and you don't lose so much of the inference capability. And see here on the right, you can take a look at how the various types of GGUF, Zephyr fine-tunings that there are. And you can see where they range from, there's a small one if you just cared about size, all the way down to the middle. And they have a measure of their quality after they've been used the method. And this is all also available on the Hugging Face site. So that's really exciting, because now you have the ability to self-host your models, right? So I'm sure all of you have seen where ChatGPT has been down. I think it's still down, or half down, for the last day or two. Now just think if you wrote your systems to go against ChatGPT and you're depending on that, right? That would be a disaster. So this gives you a strategy where you can basically get the same production capability that they have, except you don't have token charges, because you pay by the token for your communication with these models. And the models can be and you can fine-tune the models for tasks faster. There are techniques now that you can fine-tune a model in just a few hours, as opposed to like a month worth of CPU time on an A100 GPU. And you're resilient to outages like what we're seeing with OpenAI. And then models across the device landscape can be distributed using IPFS. So think about this, being able to take the continually using RAG techniques to basically tie in vector databases to execute against these models, and you keep track of these things. And then after some time, what you do is you can leverage the data to fine-tune the model for the specific user, and then redistribute that model to all of their devices at once, leveraging IPFS, and then keeping it in sync. And you can see the models would get iteratively smarter and smarter and smarter with respect to that user. And then you can take commonalities from out of that and then build the base model up faster as well. And you can opt in to doing this. So because our system is all decentralized and really user-centric, users can opt into these things and actually maybe even earn money off of being able to share their data. And this is what we considered as the big, hairy goal, is to be able to support the concept of, in the United States, of healthcare for everybody. Because right now, healthcare for everybody in the United States with Obama, what they call Obamacare, unfortunately, it just means that healthier, wealthier people, end up paying for the sicker, poorer people, which ends up being a big political thing, right? But what if you can use the data for the sick, poorer people, which is the most valuable data out there, right? And if you have them opt in to sharing all of their demographic information with it to researchers who really don't want the anonymous data, we need the specific demographic data, especially when it comes to training models to overcome bias. Because right now there's a huge problem with bias in models, because, quite frankly, most everything on the internet out there, especially in the United States, it's kind of based on, white males, pretty much. And so, as a result, there are some problems that can result from not having, ethnic diversity in your data, in your models. And then, I mentioned already, you can custom fine-tune, leveraging the user identity from Ori, and that can be done as a service. This is one of the things that we're planning to do. And It can be done as just an integration. There's lots of options that we're going to be talking, about later about this, but it opens the door to being very specific in the use of these models for various tasks. And because we decentralize our platform in a way that they can discover each other, the instances of each other based on their policies, well, then now you have all kinds of ways to pull in other data that might be important, right? An example of that would be like I have this Oura Ring on. I use this to manage my sleep patterns, right? I don't sleep hardly at all, but but this tells me like if my sleep score, my total readiness score is like 66 or something when I get up when I get up after 3 hours of sleep, I know that, man, I should get another sleep. I get this thing over 70, and then that makes a huge impact on my productivity for the day. So I know when I'm overtraining as well, because I train a lot as well. And so it helps me from keeping injured, getting injured and all that. So, but what if I can make all this context data, which would be very important, for things like mental health, to know when this person's gonna be stressed, gonna break down, and then be able to use that in combination with all these models to help enhance the user's life. So that's the things we're working on. And, if you have any questions, I'd like to field some.
We're about 5 minutes behind, but if anyone has one quick question, we can. Travis will be around also later on today. And thank you, Travis.
Thank you.
Yeah, he likes to talk about the Dallas Cowboys. So I think you're going to have to argue with him a little bit too.
Yeah. Yeah.
Thank you.
Y'all got us, but.